कि ये प्रॉब्लम आपने कल की थी?
यस सर, की थी।
व्हाट इज द आंसर? क्या मिला था आपको?
एक सेकंड सर, चेक करता
क्या आंसर मिला था? जल्दी।
295/314.5।
नहीं, पूरा क्या आया था आंसर?
सर मैंने सॉल्व नहीं किया।
कोई somebody has solved it? Okay, let's do this numerical. ठीक है, के बाद we'll start. Okay, now this is saying find the transfer function, this one system shown in the figure. First आपका क्लास भी वैसे ही है अब, आई थिंक 5th सेमेस्टर 6 में, और आप में कोई फर्क नहीं रहा है. You are till you will reach 8, you will become 7th, you will become same thing. अभी कोई शौक नहीं है पढ़ने का. Anyway, let's first identify the step number 1. Is to identify the forward path gains. Forward so there are two forward path gains. Number one, T1 will be this straight one, 1 5 10 1 1. So that is 1 into 5 into 10 into 1 into 1, it is equal to 50. Number second is 1 10 2 into 1, 1 10 2 into 1, that is 20. So this is number one. Now next, what we have to, step number 2 is to identify the loop gains. Step 2, to identify loop gains. So you can see loop gains, how many we have. Let's say loop 1 in this case will be this one, y2, okay, y3, then we will have y4, then we will have y5, and we'll back to the y2. So loop 1 will be y2, y3, y4, y5, and back to y2. So that will be 5 into 10 into 1 into minus 1, and that is coming out to be 50, minus 50. Similarly, loop 2 will be y3, y4, and y3 back. The small loop. So that is 10 into 10 into minus 1. That will be minus 10. Loop 3 will be, in this case, y4, y5, and back to y4. So that is 1 into minus 2. So that will be minus 2. Loop 4 will be this small one we can take. Y7, this is again y7, y7. y7 into y7 is 0.5 minus 0.5. Okay, loop number 5 in this case will be, loop number 5 will be y2, y7, then we can have y5 and back to y2. y2, y2, y7, y5, back to y2. So these values are 10, 2 and minus 1. 10 into 2, and then we have minus 1. It comes out to be minus 20. So this was step number 2. Step number 3. Step number 3 says identify non-touching loops, loop gains taken 2 at a time. Identify non-touching loop gains taken 2 at a time. Okay, so very clearly loop 1 and loop 4 are not touching. That means this loop and 4 are not touching. Okay, then loop 2 and loop 4 are not touching. Loop 2, this one, y3, y4, y3, yeah. Loop 2 and 4 also are not touching, and loop 3 and 4 also are not touching. So this is the combination we have. Number 1, we have loop 1 and loop 4. They are not touching. So you can say loop 1 and loop 4 minus 550 into minus 0.5, that's 25. Second is loop 2 and 4 also are not touching. 4 is not touching with anyone. Loop 2 and 4, that means minus 10 and minus 0.5, that is 5, half of 10. Third is loop 3 and loop 4. 1, 2, 3 are touching with each other. That is minus 2 into minus 0.5. So that will be 1. Half of 2 is 1. Okay, next step is step number 4. Sorry, there is one more. Yeah, that's one more. Loop 2 and loop 5. They are also not touching. Loop 2 and loop 2 is this one. And loop 5 is this one. Yeah, that's also not touching. So loop 2 and loop 5 are not touching. That is minus 10 into minus 20 will be plus 200. Okay. Step number 4. Step number 4 is non-touching loops taken 3 at a time. Identify non-touching loops taken 3 at a time. So we need to identify this. None. You can see because second, third, fourth, they are all touching. First also. First, second, third, and fourth, they are all touching. So when they are touching, so there is no possibility of non-touching loops taken 3 at a time. So we can write here completely none. So the next step is step 5 is to find delta. Delta will be 1 minus summation of loop gains. Summation of loop gains is minus 50 minus 10 minus 2 minus 50 minus 10 minus 2 minus 0.5 minus 20 plus minus and then again plus formula. Then we have summation of the non-touching loop gains taken two at a time. That will be 20 plus 5 plus 1 plus 200. Okay. So this comes out to be, if you calculate this, delta will be 314.5. Please check this values also. So delta 1 is forming by eliminating all the loop gains that touch the path number 1. So it will be 1 minus minus 0.5. Can very clearly see. This is the first path. So loop number 1, loop number 2, loop number 3, and fourth. Only this one is not touching. So 0.5 we'll write there. So that is 1.5. So delta 2 in this case will be 1 minus minus of 10. That will be 11. Okay. So 11. Now we will use the Mason's gain formula T1 delta 1 C by S using Mason's gain formula transfer function C of S divided by R of S is equal to G of S. So let's find it. So in this case, G of S will be equal to T1 delta 1 plus T2 delta 2 divided by delta. So G of S is, T of S is how much? 50. T2 is 20. Okay. 50 into 1.5. 50 into 1.5 plus 20 into 11. And then delta is how much? Delta is 314.15. If you calculate this value comes out to be 937. So G of S is 0.937. Then another, if you have been given like this transfer function, you have to find the transfer function. So you have to draw the first signal flow graph for this one. It's a very simple to draw the signal flow graph. First, before doing this, so for this one, solution will be like this. Okay, we need to take the Laplace transform of the network. And showing various loop currents and node voltages. Okay, so I have to draw this. I cannot copy this. Okay, this is R1, this is L1, this is R2, this is L2,
वेट करो सर, यहीं आएंगे।
तंजीब,
यस सर।
कितना टाइम हुआ ये?
सर अभी जब मैंने आपको मैसेज भी किया पहले, फिर जब आपने मैसेज का रिप्लाई नहीं दिया, फिर मैंने आपको कॉल ही किया।
ओके, अभी ठीक आ रहा है?
यस सर, आ गया वापस।
टू रिकॉर्ड अगेन, रिकॉर्ड तो हो रहा है। समथिंग रॉन्ग विद द नेट, ठीक है। ओके, नाउ इट्स ओके।
यस सर।
ओके फाइन।
सर ये आप रिपीट कीजिए प्लीज, क्योंकि ये हमने नहीं देखा।
कहाँ से नहीं देखा?
सर आपने तब खाली डायग्राम बनाई थी।
Okay, now what I'm doing, I have drawn the diagram and I have changed to the Laplace transform, simply Laplace transform. You can see I have written the Laplace transform values. Then I am writing the equation. So equation number one will be voltage. If this current I have to find, current will be this voltage at this node, that is Vi of s, minus this voltage divided by the impedance. That's I'm writing. Simply, if I have to find this voltage, this we have V1 of S. So this voltage will be the difference between the current, that is I1 of S minus I2 of S, multiplied by this impedance I2. That's what I have written. This is equation number 2. Is it clear now? Tanjeev?
Yes, sir, clear.
Okay. Now, if I have to write I2 of S, so I2 of S, how I'm going to write?
कैपेसिटर दो ही थे
दो ही थे. I think third is also there, no? Oh, yes, third is also there here. Anyway, no problem. It is here only. It will not make much difference. Yeah, you're right. This value is okay, and this current across this is V naught of fine. So I have made another capacitor also. I think I will draw the diagram. There is jumbling. I don't like this. Okay. Okay. So fine. This voltage here is V naught of S. That will be same here also, V naught of S. SC3 or C3S, one and the same thing. Okay, I2 of S will be here now, flowing through this. So that will be V1 of S minus V2 of S divided by R plus R2 plus L2S. Call it third equation. Then V2 of S will be, so if I to find this voltage now, so that will be I2 of S minus I3 of S. Two currents are flowing, so can take difference of these two currents multiplied by the impedance, that is C2 of S. SC2, and then the same thing. Okay. Now after that, I'll find I3 of S. I3 of S will be difference of these two, V2 of S minus V0 of S divided by R3. Let's call it equation number 4. This is 4. Okay. Then you're finally V0 of S. V0 of S is current flowing through this is 1 only and impedance is single only. So I3 of S divided by SC3. 6. So in order to satisfy these currents, I need to draw the signal flow graph. So how I have to draw it? You can see. Alternatively, I need to take. So I will write signal flow graph can be drawn as, okay, so let me okay, fine. So okay, Okay, just a second. I need to satisfy the above equations. That's all. Now, first, what is the input that I will be writing here? Input is Vi of S. So it is input node voltage. And output is V naught of S. Now, in between, I have to satisfy it. What is my first feedback? Feedback means which is in the denominator. Feedback means which is in the denominator. First feedback is R1 1 by R1 plus L1S. So this is first feedback. Okay. Now what is the second feedback? I have to go it accordingly. Second feedback is this one, 1 by CS1. So that will be 1 by SC1. What is the third? Third is R2L2S 1 by. So I'll be using this. Just a second. What is the fourth? Fourth one is I have to satisfy it. I'll tell you what I'm doing. Just wait for the second. Okay. Sorry. This is wrong. Mistake. This is now fine. This is let me write first. I'll not write the feedback first. Just a second. Okay. What is the third one? 1 by leave the feedback R2 plus SL2. Okay. What is the fourth? 1 by whatever is the denominator, those are the feedbacks. SC2. What is the fifth? Here, 1 by R3. 1 by 1. You have to satisfy it. I'll show you. Then 1 by SC3. So these are impedance values have to be written in a transfer function value. So now, what are the voltages first we'll be using? Now, because this voltage, first current, that is I1, is difference of what? I1 of S is difference of V1 of S, and second voltage here has to be V1 of S. Vi of S and V1. Similarly, current number 2, I2 of S is what? It's the difference of V1 of S minus V2 of S. So similarly, current here, what we call this current, okay, V2 of S, next current is I3 of S. Yes, fine. So this is I3 of S. What is this current I3 of S? It's a difference of V2 of S minus V0 of S. V2 of S minus V0 of S. Now see, although we are getting here this current, we can get, suppose we have a current, we are talking about a current I1. I1 is basically what? V1 of S, that is Vi of S minus V1 of S divided by R1 plus L1 of S. But here in this case, we need to nullify this, because if we are taking output by input, so we need to nullify this in the feedback. That means we need to put 1 by R1 plus L1 of S. Similarly, this we will be getting here also in negative. See, negative value we are getting with V1 of S. So we are taking the negative value of V1 of S. Here we are taking positive value. V1 of S, I1 of S will be V1 multiplied by this. Whereas if we talk about this V1, it will be V1 of S, but with negative value. Similarly, in the second feedback, what we'll be getting? We are getting S1 positive with I1 current. So here S1 is positive with I1 current, but once we are taking it with I2, it will be negative, negative minus ISC2. Similarly, reaching here, so we are getting this positive while we are taking this current I2. If we are getting this current I2 will be V2 by I2 will be V2 by R into this R2 plus SL2. But if I are talking about the, sorry, it will be with V1, it is positive, this here. So you can see I2 is, this current I2 in the output is V1 multiplied by this. Similarly, if I am trying to get now, what I am trying to get, I am trying to get this minus V2 divided by, so if I have to get minus V2 divided by this also in the term, so that term, in case of I2, I have to get this, then I have to get it in the feedback. I have to get what? I have to get negative in the feedback. Negative what? Minus 1 by R2 plus SL2. Reaching here. Now coming to this V2. Now V2 is multiplication of I2, I1 by SC2. V2 is multiplication by, here it's the output, I2 multiplied by 1 by SC2. Okay. Now again what I have to get? V2 is again minus I3 multiplied by 1 by SC3. Say here I have to get minus SC2. This is in feedback. Sorry, this is SC1 here. Sorry, by mistake. SC1. So this is SC2 here. So I am getting this with the, so if I have to get the V2, it is V2 is first here output I2 multiplied by this. And if I am talking about V2 here in the feedback, so this will be I3 minus I1 by SC2. Similarly, now coming to the next voltage, that is your V0 of S. V0 of S is basically simply multiplication of, that is here only. We don't need to do any manipulation. But for I3 of S, we need to make manipulation. I3 of S is V2 of S divided by R3. So I2 of S is what? V2 of S divided by 1 by R3. We are getting it. But what we are not getting is I3 of S is V0 of S minus 1 by S3. So we will get that. If we take this value if we consider, then we have to say the feedback value. Feedback value is this one. What is 1 by R3? So 1 by 1 step we have to do it. Is it clear or not? Tanzib?
Yes, sir, clear.
नहीं, अगर समझ नहीं आ रहा तो I will go back. 1 by 1 क्या लेना है? Repeat. Now what's important here? Important here is to consider the voltages and currents. How you have to consider them? It's obviously that we need to consider them alternately. Why? Because current I1 is dependent on the voltage V1 of Vi of S and V1 of S, leaving the impedance aside. Whatever the impedances are, you go by one, writing them. You will get the result. So impedances, that means in the denominator, that will be 1 by R1, 1 by SC, then 1 by 1 you are writing in. If you are going from left to right, then write it like this. If you are going from right to left, it's your choice. Wherever from you are starting, but write them in the sequence. So denominator values, that means 1 by this feedback values, you are writing them 1 by 1. So now, because current I1 is dependent on both the voltages, that means current and voltages have to be alternate. How? This current, okay, so what is this current? This is I1 of S current, okay. I1 of S current is an output here. That should be multiple of what? That should be multiple of V of 1S into Vi of S into this feedback value. That is 1 by this. So we are getting this part of, first part we are getting. Now what we are not getting is the second part. So second part we have to get with V1. It's also, I1 of current is also depend on minus V1. So minus, how we are getting? We are getting in the feedback like this, minus. So then in this case, this multiplied by this, because direction of the signal flow has to be in the reverse. this voltage V1 of S multiplied by this feedback value minus 1 by R1 L1 of S will be I1. So together in totality, this current is this thing multiplied by this thing, and here this thing multiplied, that means Vi of S multiplied by this value 1 by R plus L1 of S, and also minus, because minus is there, V1 of, so we are satisfying this equation. In the similar way, we have to move forward. So now if we are talking about the V1 of S, V1 of S depends on I1 of S multiplied by 1 by SC1. So here it's clear that V1 of S, if we are moving towards this is output. So I1 of S, this current here multiplied by this gain, this is the gain, multiplied by this gain will be equal to this voltage. But again, the V1 is also depend on current I2. So how we are going to get this? That we are going to get from the feedback. So what we have to get in the feedback? This value, minus values we have to get in the feedback. So I2 into minus 1 by SC2 will be nothing but V1. In totality, V1 will be summation of this one. So this will continue like this. Is it okay now? Tanzib,
Yes, sir.
any questions? Roll number 10. 8, roll number 8. 6.
Yes, sir, clear.
Okay, please go through it again. ये बिल्कुल systematic जाना है. तो this will be in the conventional exams. This can come. So rest again. You have to use the Mason's gain because he has told you. I think what is the question? Yeah, he has told you to use the again. You have to go by the forward paths, and again you need to solve this yourself from here onwards. This you need to solve. I hope you can solve from here. So forward path gains will be how many? There will be only one forward path gain. That's clear. Then how many loops will be there? There will be 5 loops. 1, 2, 3, 4, and 5. It's a straightforward question after that. Only this much you need to carefully draw it, and then it's a straightforward question. Okay. Now moving ahead, let's start the chapter number 2. We are a bit late, but it's fine. I missed some classes. I'll be taking some introduction. It's a very important chapter, time response from the GATE examination point of view. Very important chapter. 1 or 2 questions you definitely get from this chapter. 3 marks to 4 marks. Time response. Analysis of first order and second order control system, and okay. Now, what is the, sorry. I'll not be writing complete details here. So you go through this. This is a theoretical. Okay. Introduction to this is in the response of a system as a function of time. T is known as time response of the system. It's a very simple thing. If we are talking the time response, then whatever the response is output. There is input, response to stimulus. Stimulus is sometimes called input also. So whatever the response of the system is, when it is on the base of the time, then it's called a time response of the system. So first is response of a system as a function of time t is what? As a function of time t is known as, it's called time response of the system. Basically, if we are giving some input to the system. Then after processing that input, how much time it takes to give output, what type of output it gives. So when we see the response of that, that analysis of any system is called time response of a system. Time response, if you see this time response, is basically the summation of sum of transient and steady state responses. This is sum of transient plus steady state response. So time response itself will be consist of two parts. That will be, it will consist of transient part, and then it will consist of the steady states part. Now, first part we'll consider the transient part. Now, what is basically a transient part? Transient response, we'll call them transient response and the steady state response. Now, transient response in the control system is defined as the part of the time response that goes to zero as t tends to infinity. That's the, what we call it. It's a part of a, it's a part of a control system. Okay. It's a part of the control system it's a part of the control system time response. It's a part of the time response, we can say. I'm going to write this. It's a part of the time response that goes to zero as t tends to infinity. What's the meaning? What's the practical meaning of this? Practical meaning is, if you are operating any control system, and then while we are operating the control system, as the time progresses, this response will die out. This response will die out, as we have damped, underdamped, all those systems. So it's a part of that control system before reaching to the steady state. As the time will progress, this part of the response will die out. This part of response will die out. Then second part is steady state response is simply steady state response is simply the part of the total response, the part of the total response that remains after transient has died out. After transient has died out. So this part of response, when we are talking about, as we are talking about the steady state, we are talking about the time response of the system. I have told you time response of the system consists of two parts. Number one part is a transient part. Number two is a steady state part. Now in first part, as the time progresses and it reaches towards infinity, the time response will go to zero. That time response will go to zero, and that response will be called transient response. Now, once the transient part dies out completely, that means it has been vanishes completely, then the part which will be remaining, part of the response which will be remaining, that part of the response is like this. I have an example. That part of response is steady state. Now we have any process, we expect a response from it. We have given input to the control system, and that has progressed after a series of milestones in the processing, whatever the processing plant it may have. Then after that, we expect that response will be like this, and then finally it will settle down at this value. So this part of response, as the time progresses and it reaches towards the infinity, this part of response is the transient part. And as the time will progress, this will die out. That means it will go from here and finally die out. So this is the time, say t, and this is the response of the control system, say C of S. Sorry, in time domain, it is C of t. Now let's say this is a time 0 here, and this is a time, this is what time? This is t equal to infinity. So at infinity, as the time progresses, this response will die down, this response will die down, or it will go to 0 as the time progresses, and finally it will settle down at some value that will remain after the transient will die out. That part is called a steady state response. So it should be very clear. These are the two parts of a time response. Okay. Now, next is, when we talk about the practical control systems, all practical control systems which will exist, they exhibit or they behave, they show some behavior about the transient phenomenon to some extent, and then finally they attain the steady state. So the practical control systems, they will exhibit or they will show the behavior for the transient response to some extent, and before that response will die out, they will attain a steady state response. So this is a practicality about all the control systems in nature. The poles and zeros, we will talk about these poles and zeros of the system transfer function. They will control the time response. So who will control the time response? The poles and zeros of the system transfer function will controls the response of the, so that we'll see later on, controls the, in the progressing lectures, response of the system. So poles and zeros are very vital, and poles and zeros of the system transfer function will control the response of the system. Now, when we are designing any sort of a control system, you should always remember, when we are designing any sort of control system, input signal to the control system is not known. We don't know the input signal ahead of the time. And instantaneous input can be expressed also. So input signal to control system is not known ahead of time. So before time, we don't know what type of input we'll provide to the control system, or what type of disturbance it will be encountered with, what type of disturbance, what type of disturbance will occur to the control system. That's not known ahead of the time. And that instantaneous input, that is at particular time, there will be some input. We cannot express that analytically also. So it's difficult to express also. It is difficult to express instantaneous input analytically. It's difficult for us to express this input also. So any control system we are operating, input signal will not be known ahead of the time, or any sort of disturbance, it will any sort of disturbance can come to the system that's not known ahead of the time. That's also an input, although that's a disturbance, but that's also an input. So we cannot express that at that instantaneous input, that cannot be expressed analytically. So for example, now we'll take an example of the aircraft. For example, we have an aircraft. Now, in case of aircraft, when aircraft is manufactured, then what we do, we have to make it flight worthy before it actually takes off. So when we manufacture the aircraft, when we first of all we design the aircraft, and once we design the aircraft, we subject it to various types of testings. Why we subject to the various types of testings? Because we make sure that this aircraft should be made flight worthy. This should be in a situation. This should be in a state that we can make it flight worthy before actually it will take off. That we should be confident that uh, we should make it flight worthy. That means it should be able to fly once we start this aircraft. Once an pilot will start this aircraft, and then it will take off from the runway, and it should be able to fly safely in the atmosphere. So that's very important for us. So for that, the types of there can be a lots of disturbances can occur. The types of disturbances that will occur externally to the aircraft that it encounters during the flight is not known ahead of the time. So what is here? So I write a 1 point here. Here aircraft is made flight worthy after flight worthy before actually it will take off. It takes off. So this is the control system engineer's job. Then if he is confident, also it's very important to mention here the type of disturbances which this aircraft will encounter during the flight. During its flight, the different types of the disturbances which it will encounter is not known ahead of the time. We don't know what is coming up while we are flying in the air. So type of disturbances are not known ahead of the time. Type of disturbances are not known ahead of time which an aircraft may encounter during its flight. So while this aircraft is flying, whether the rain will come, whether the hail will come, whether the visibility will be poor, whether there will be something other problem, the wind will be blowing at a very high speed, which an aircraft cannot control. So we don't know what will be coming up. That's why while we are flying in the winter or later part of the summer, or you can say after the rainy part in the December, January, or somewhere in the November, we always see that whether the visibility is fine for us. All the parameters before well in ahead are seen by the air traffic controller that everything is fine for us, and then they will allow us to fly. So, but whatever after that, taking every precautions, only God knows what is coming up. Maybe the visibility will go much poor while we are in the air, or maybe there will be some other disturbances. So those type of disturbances are input to this system. So those are not known ahead of the time. We don't know before the time. Nobody knows that well before the time. So hence, before the aircraft is launched into the space, the laboratory tests are done using what? Test signals as though they are disturbance. So what we do as an efficient engineer, or as an efficient engineer who tests it. So what we do before the aircraft is launched into the space, the laboratory tests are done, and those tests are done as though the signals are given as input, which may be treated as an disturbances that an aircraft can encounter during its flight. So before an aircraft is launched, before the aircraft is launched into space. Okay, the laboratory tests are done. So laboratory tests are done. Okay, using what? Using test signals. Using test signals as test signals as though they are disturbances. So what we are doing, if we have to make it flight worthy, that means we make sure that aircraft flies without any smoothly in the aircraft without any problems. Then as aircraft, while before launching it into the space, it will be subjected to the numerous tests in the laboratory, and those will be input signals, test signals, as though those signals are disturbances, which it may encounter while it will be in the space. The result of these test signals will determine what? It will determine the transient and the steady state behavior of the aircraft. So, what's the objective? Objective is the result of test signals will do what? Test signals will determine what? Will determine result of the test signals will determine the transient and steady state behavior of the aircraft. So it is very clear, we'll be subjecting this aircraft to the numerous tests, and objective of these tests is while it will be in the transient state, that will take off, while it will be taking off before the autopilot is switched on, then we'll see what is the behavior, and once the autopilot is switched on, again we'll be seeing what is the behavior of the aircraft, whether it's worthy to fly or whether there are some flaws which we need to correct. A corrective action will be taken for those types of flaws. Okay, if the test report is satisfactory, now we have subjected to the numerous tests. Objective is that we need to say the behavior in terms of steady state and transient and steady state behavior. Now, if the test report is satisfactory, then we can conclude rather that the behavior of the aircraft in terms of stability and time response will be satisfactory for any type of disturbance. So what I'm saying here now, if after subjecting it to the numerous tests, if the test report is satisfactory, then what it says, we will say that the behavior of the aircraft in terms of, it means what? It means behavior of aircraft in terms of stability, and time response will be satisfactory for any type of disturbance. So once we have subjected, maybe the test signals, we'll see what are the test signals. Basically, you already know, you have studied them. Step is there, ramp is there, then parabola is there, but mostly we use step, and then also we use ramp. Impulse we use, parabola we use. So these are test signals, different test signals. It will be a combination of test signals can be also there. So if the report comes out to be satisfactory, that means the aircraft in terms of stability is also fine, and in terms of time response, when we are talking about the time response, there is a transient response as well as steady response is fine. So any type of disturbance can occur, and aircraft in the air can withstand those disturbances, and the operation of the aircraft can be smooth while it is in the air. So that's what for designing, for analyzing and designing control systems, we must have this type of comparisons for the time response of various control signals. So we have to do this comparison in the sense that we need to subject an aircraft to various types of tests, although as though those signals are what? As though those signals are disturbances. Okay, so this type of comparisons is very necessary. So this will be then accompanied by subjecting system to various typical test signals and recording the time responses, so that we can see in the report. So once we have various test signals, we will subject the system to various test signals, and that will be typical test signals, and I have talked about those. There can be step, there can be ramp, there can be parabola, there can be impulse. So these are typical test signals, and then we can record what? Recording the time responses. We'll see there whether the response is fine or not. That can be done. This type of comparison can be done. Okay, so the use of these test signals, we use test signals because there has to be a correlation. That means there has to be a synchronism between the response characteristics of signals to the typical test signals, and also to the capability to cope up with the actual when the disturbances will come. So finally, the meaning here is, the conclusion here is, while we are subjecting an aircraft to various types of typical test signals and recording their responses, we are making sure that while the aircraft is actually in the air, then it will cope up with the capability of the aircraft, will cope up with it will cope up with various types of disturbances that it may encounter in the air. So this was something, an introduction to the time response, that how we have to manage the time response, what signals we have to look into, and how we have to make a control system worthy, efficient, or operable. It should be operational before we actually operate it, before actually operating it in a space or somewhere we want to operate it. Maybe it's a different type of control system. So while we operate it, before we are actually going to operate it, then before that we have to make sure that its stability and time response is as per our requirements, So here again I am talking about the transient component. So this transient component is that component which usually decays to zero as time increases. It's the function of, so we'll be talking about this transient component. Transient component is that component in which that component will decay to that component which will decay to zero as the time increases. As the time increases. And it's a function of system dynamics and is independent of input quantity. So this is actually a function of how the system dynamics are, how the system is made of. Function of system dynamics and is independent of input quantity. System dynamics means what type of system we have, what are the ingredients we have used in system, what are the various parts, subsystems of the system. Whatever the input you give, transient part has no role in that case. It's not dependent on the input quantity. That we'll be seeing later on also. Now, second component is steady state component. Now, in this steady state component, this component of system response, you already know this, will remain there after the transient component will die out or it will decay. Once the transient component will decay, then the whatever the component that remains there will be which one? That's a steady state component. But important thing in this case is it's a function of both. It's a function of system dynamics and as well as the input quantity. So this is the component of the system response, component of system response, which remains there after the transient component has decayed. And it is function of both. What are those? System dynamics and input quantity. System dynamics will be always there. So it's a function of both. Time domain analysis. If we talk about the time domain analysis in now, the steady state, this is the study of the control system in time domain that will involve the evaluation of transient and steady state response of the system. In the design problem, we should know the specifications given in terms of in the design, whatever we have to design, the specifications usually are given in terms of transient and steady state performance, and controllers are also designed so that these specifications are also met by the design system. So in nutshell, time domain analysis, the steady state is the study of the control system in time domain. It's in a time domain study that essentially will involve the evaluation of transient and steady state responses of the system. So that is a very simple. So this was the introduction. So next class, maybe day after tomorrow, inshallah, we'll be going to the typical signals. I will be going fast. I think you have studied, Tanzib.
Yes, sir.
You have studied these signals in signal and system. What about step,
Yes,
ramp?
sir.
So I'll be going
Yes, sir, yes,
fast. ठीक है, उनको जरूरत नहीं है. Zeros फर्स्ट ऑर्डर पे हम जल्दी जल्दी जाएंगे, ये उतना डिफिकल्ट नहीं है. तो देन वील मूव टू द सेकंड ऑर्डर इज द मेन. ठीक है, बड़ा इंपॉर्टेंट चैप्टर है ये. इसमें न्यूमेरिकल्स बहुत आते हैं गेट के लिए. इट्स अ वेरी इंपॉर्टेंट चैप्टर. ओके, वी विल कंक्लूड टुडे. सो इंशाल्लाह विल.
सर लॉग लेना है कि नहीं?
और क्या लेना, आज जरूरी है. इट्स अ मैंडेटरी क्लास, मैंने पहले बोला आपको. दिस इज नॉट एन ऑप्शनल क्लास.